Okay, so in part two, we're going to go ahead and finish determining the oxidation state. We had just done these first two, so now we're going to finish off with looking at the oxidation state of the carbon that's in our carbonate ion. Again, since this thing is an ion and it has a -2 charge, my oxidation states must add up to -2. Oxygen gets priority to be -2. So since I have three -2s, that adds up to -6. And since this whole thing has to add up to -2, that means the carbon must be a +4. And again, since there's only one carbon here, that means the oxidation state on this carbon is +4. Now we might be wondering, okay, what does all this oxidation stuff here, what does all of this have to do with writing equations for reactions? Well, we just looked at some of those cases where we had those non-metallic oxides. And so we're going to get things like this that are non-metallic oxides, and it'll help tell us what the formula is going to be. So for example, let's say that we were trying to finish this reaction. We have SO2 plus H2O. We want to know what goes on the other side of the arrow. Well, the first thing we have to do is figure out what kind of a reaction is it. Now, obviously on this slide here, we're dealing with compositions and decompositions. So it can't be a decomposition reaction because decomposition reactions only have one reactant. In this case, we have two reactants. So it must be a composition reaction. So we go to our blue cheat sheet and we look up our composition reactions. And once we establish, yes, it's composition, now we need to figure out what category number is this? Well, I've got something plus water. And if I look down on my choices, one, there's no water there. No water. Oh, I've got plus water in number 4. I've got plus water in number 5, and that's it. So does it match either 4 or 5? Well, I have oxygen, so it's an oxide, and sulfur is a non-metal. So this actually matches composition number 5. So I'm going to use that guideline on my blue sheet there to help me finish this out. So we'll zoom in. Here's our rule from our blue sheet for composition number 5. So it tells me when I have a non-metallic oxide plus water, I get an acid. And so I'm going to get an acid as my answer here. So which one am I going to get? I've got H's, S, and O's. Well, I've actually got two choices because I know two acids that have H's, S's, and O's in them. I have H2SO4, sulfuric acid, but we also have another acid that we know of, sulfurous. So which one do I put? Which one am I going to get? Well, on my blue sheet, I have this little note here that tells me that the non-metal must retain its oxidation number. So in this whole mess here, we have H's and O's, but my non-metal, which is part of my non-metallic oxide here, is sulfur. So when it says must retain its oxidation number, that means whatever its oxidation number on this side is, I want to keep that same oxidation number on the other side. So my first step is to figure out my oxidation number for the SO2. Well, it is a compound, so that means all the oxidation numbers must add up to 0. Oxygen gets priority to be -2, and so 2 -2's gives me -4. That means that the positives must add up to +4. There is only one S, so that means my S has an oxidation number of +4. So I want to make sure that on this side, I choose the one that has an S with an oxidation number of +4. So if we look at this, I've got H2SO4, and in this case, must add up to 0. So I can actually look at this as an ion. I know this has the sulfate ion in it, and I know sulfate is -2. So what is the oxidation number on the S in sulfate? Well, it's the ion, it's got to add up to -2. Oxygen gets to be -2. There's 4 -2, so that's -8. And that means that the S, now it's got to add up to -2 here, so that means the S must be +6, because +6 and a -8 gives me a -2. So in this case, the sulfur has an oxidation state of +6, which is not what we had over here. So I'm thinking sulfuric acid would not be a good answer for this question. So let's check out sulfurous acid. Now, sulfurous acid has the SO3 ion, or the sulfite ion, hopefully you know, which is also -2 in its charge. So what's my oxidation state here? Again, it's an ion. It's got to add up to -2. I've got 3 O's in it. O always gets to be -2, so that means I have a -6 piece. So what does the S have to be? Well, in order to add up to -2, the S has to be +4. So in sulfite, the sulfur has a +4 oxidation state, which is the same thing that we have on the other side. So that means this is my answer to the question. I'm going to end up with sulfurous acid as the acid formed in this case. And that's why that has that statement that it is. So there's one example of a tricky one. We have to do a little work to figure out what it is. Let's look at another example. Let's say I have sodium sulfite, and I want to know, well, what's going to go on the other side of the arrow? Well, just like we always do, the first question we have to ask ourselves is, what type of a reaction is it? Well, I only have one reactant. Nothing else on that side of the arrow. So that narrows it down. There's only one kind of reaction type where I only have one reactant, and that is decomposition reactions. So I know this is a decomp. So now to figure out who my products are going to be, I go to my cheat sheet, and we've got to figure out, okay, well, what kind of a decomp is this? And it's, again, it's Na2SO3, sodium sulfite. It's not a hydrate. It's not binary. Binary compounds are just two elements, like Na2S. Just okay. It's not binary compound. It's not a metallic oxide. There is O in it, but it's not a metallic oxide. It's actually a metallic sulfite. So it's not a number 3. It's not a metallic chlorate. It's not a nitrate. It's not a carbonate. It's not a bicarbonate. It's not an acid. So the only thing left is metallic oxyanion. What the heck is an oxyanion? Well, the word anion means something with a negative charge. Well, I have sodium sulfite. Well, sulfite is an anion. Sulfite has a negative charge. Oxy, that probably means oxygen. So it actually is. An oxyanion is just any negative ion that has oxygen in it. So most of our polyatomic negatives, all the 8s, all the ites, those all have oxygen in them. So sulfite is actually an oxyanion. So this does match number 9 on our list. We have a metallic oxyanion. So we can look at number 9 to figure out what our products are going to be. Now again, one of the tricks I usually like to do is I usually like to write a word equation here. So I have sodium sulfite as my reactant. There's my arrow. Now I look at my sheet here. It says I get a metallic oxide. So I want to replace the word metallic with who my metal is. In this case, sodium is the only metal in this whole thing. So I'm going to get sodium oxide. So that's easy. And I get a non-metallic oxide. So we know our last word's going to be oxide. Well, who's our non-metal? In this case, it's the sulfur. So I'm going to get some kind of a sulfur oxide, which is a non-metallic oxide. It's a covalent compound. So I don't know how many sulfurs and I don't know how many oxides yet. So there might be some prefixes that go there that I don't know yet. So let's look at our formulas here. Okay, so sodium oxide, well, sodium is Na+1, oxide is -2, so that's ionic. So that one only has one option. It has to be Na2O. So that's my metallic oxide. Now for my non-metallic oxide, I'm going to have some kind of an SO something. I don't know what my numbers are going to be on that. But again, we have our little statement here. We have our non-metal. In this case, my non-metal is the sulfur, and it says it must retain its oxidation number. So just like we did before, I'm going to look at this sulfite ion and figure out, well, what is the oxidation number on the sulfur here? It's got a -2 charge, so that means my oxidation numbers must add up to -2. Again, oxygen gets priority to be -2, so 3 of them means I've got -6. That means that in order to add up to -2, the sulfur must be +4. So we actually just did this one in the last problem, so if you remember, it shouldn't surprise you. So I need to come up with a formula where sulfur is +4. So if sulfur is +4 and if oxide is -2, the only way I can get this thing to add up to 0 is if I have SO2. That way I'll have two -2s. That gives me -4 overall. I have sulfur with a +4 charge. And so that would add up to 0 and give me a compound. So this would be my answer here, just SO2. You wouldn't write the charges on your final answer. So my non-metallic oxide here would actually be sulfur dioxide. And then balancing would be my last step, but it's already done. Don't have to balance this guy. So that would be my answer for that one. That's how you do decomposition number 9s. Let's look at one last example altogether. Here's our third one here. And again, first question I need to ask myself, is it a comp or a decomp? Well, I've got two things, so it can't be a decomp. So it must be a composition. Let's see if it matches any of our categories of compositions. Well, I've got a non-metallic oxide. I'm sorry, not a non-metallic. Calcium is a metal. So I've got a metallic oxide. So number 4 says metallic oxide, but that's plus water. This is not plus water. It doesn't match number 4. Number 6 has a metallic oxide plus non-metallic oxide. Well, sulfur's a non-metal, so this actually matches category number 6. So let's going to use that as our guideline to figure out what this is going to be. So here's our category number 6. Again, I like to write my words out. We're going to have calcium oxide. Sorry, this is going to be a little hard to read. Plus sulfur dioxide. We're going to get a metallic oxyanion that must retain its oxidation state. So that means I'm going to get, my metal is calcium. Now oxyanions, that means we're going to have some kind of an oxyanion that has S and O's in it. Well, I have a couple of them. We have SO3 -2, that's an oxyanion with S and O in it. There's also sulfate. Those are the two most common ones, so let's check those two out. But again, our nonmetal must retain its oxidation state. Now we've already done this one a couple times, so if I'm looking at the SO2, what's the oxidation state here? It's got to add up to 0. O gets to be the -2 guy, so 2 -2s is -4, and just like we did before, the sulfur has to be a +4 in this case. So sulfur's got a +4 oxidation state to begin with. We want to keep it a +4 oxidation state when we're done. And again, these are the same two examples that we did earlier. We showed you earlier that in the sulfate, the state of the sulfur is +6, because remember, it adds up to -2. You've got two -2s, gives you -8, so that means the positive part must be 6. So it's not the sulfate. We showed you for the sulfite, indeed, that it is a +4. So since sulfite is the one where the sulfur keeps its oxidation state, remember it was +4 on this side, so we're going to choose the one where it's +4 on the other side. So that means we are going to get calcium sulfite as our answer. And we can write our word formula as well. And check for balancing. The good news is a lot of times these come out balanced as is, so you don't have to do any more to it than that. So these are the tricky ones. This is really as hard as it gets. We have to do this work, and really the trouble spot is when we come up with these non-metallic oxides, whenever they're involved on these certain numbers here, is when we have to do this work. So hopefully you got these down, and everything else is a piece of cake. So you should now be an expert at predicting products for composition and decomposition reactions.